So we're going to demo the evolution of a trading strategy, but to do that we need to explain some basics of our model. So generally you need data, and we have lots of data. So that's just one table which holds snapshots, and snapshots are basically some asset at some time has a price, sometimes even volume. So that's our database, and for the runtime, we store it into a series, which is just a tree map of snapshots. It is also backed by hash map for easy, for faster access times. And that is our real data. Now, if you want to, let's say, evolve, we do evolutionary approach, which means that we have a genome and we calculate the fitness and, well, the solutions with the better fitness that propagate. So to calculate the fitness, we basically apply our logic to a segment of time and see how much money is made. For that, we make a paper series. We can, go there. And it's basically just an empty series which is backed by the real series, and we put values one by one into this paper series, which triggers the entire logic cycle of the application, which is from one side kind of slow, from the other side it is also an end-to-end test of the entire application, and we see if we have performance issues, which is nice. We also need to encode the genome somehow, so based from which inputs are decisions made which lead to a better or worse fitness. And this we do in a vector DTO, which is basically just a map of parameters. The special thing here is that we have a value. By the way, this is kind of like a custom number implementation which has a number and decimal part. The number is long, decimal is int. And it has a lower bound and an upper bound and a precision. So kind of we can like limit, so we don't just randomly mutate stuff. We actually have some limits where it can and can't go. The precision is also important because that way we can, well, have like integer parameter of precision 1, and in the end, if we have a series, it contains of snapshots, which we have seen before in the database. Here it's the DTO of it. And it has an indicator hash map. So that is basically for certain indicators which are calculated, we store it. And here the precision plays a role, because like if we have precision 1, so we have just integers, it's more likely that we will hit an existing value in the cache which is already calculated, instead of like we try to search for 1.001 and no, it's not the same as 1, so we need to calculate a new value. Yeah, that's for that part. Maybe at this point we can just launch the simulation and see what happens. So So let me start the application. The application works in a way that it just starts and it has jobs which you can tell it to execute. So now we can tell it to start evolve and it will start the evolution job. So that's all right. Right now we created like the first population is just full of dummy dummies. So it has like a full vector. You can see here the entries and the parameters. So the current values, for example, this is like a boolean. So lower bound 0, upper bound 1, current value null is 0 is not enabled. And here we have like how many bars, for example, should it look in the Boolean bands when doing a stop loss. And here there's the values 9,000 and or the bounds of 0 and 10,000. I wonder what the precision is. Precision is 40. Okay, that might make sense. So yeah, it did a lot of trades, probably because we do not have actually any like nothing is enabled instead of some very basic like by whatever. So yeah, let's look at the system monitor while we are at it. That window is not needed. So now we will simulate one population, so one generation, and because we have this paper job, we can spawn as many as we like at the same time and calculate them in parallel. Currently we have 160 individuals in population, so it's probably around like, it needs to calculate like 300 or 350 individuals, just like for crossing and mutating. So now we have our second population, and okay, so probably decided to fine-tune some things, to enable some things. We have like 49 trades. We made so much money in theory, and yeah, maybe we can try to see if there's something obvious in the vector which is say indicative of what it did before and what it does now. So that's still enabled. Do we have some other things? Yes, voltage cells enabled. Side is enabled. What else? Stop loss is disabled. Stop loss. Who needs stop losses? They just waste your money, right? So yeah, let's do another generation, and so no, actually, let's just let it run for a little bit, and yeah, let's come back in a few minutes to see what we get as a result. So what we saw here is also we have these gaps in utilization because there's some strategies, so also let's say some vectors in that case, have different conditions. So they do more or less trades, they check more or less conditions. Some finish earlier and some finish later. So that is the case. We see it also here on the timestamps, like most finished, let's say 45, but some took until 51 to yeah, to finish the simulation. So that's one of the reasons why we don't have perfect utilization. And yeah, now it's still calculating. We should be getting to like completion soon. And 3, 2, 1, yeah. So here, about here it was done with everything. Let's see what the result is. So we are now on generation 7. And okay, so actually funny, not much improvement. I think the highest I reached so far on previous was like 750. So yeah, we'll probably get eventually there. So there's just some tweaking and some, let's just see for the practicality. Okay, so it did some more trades. And the issue is that we do want to reuse the vectors somehow, but just binding them to, let's say, the strategy. So let's say to the exact asset and time frame would be kind of too restrictive. So we have like a rating, which is basically fitness or money made divided by volume. That's it. So that is how we quantitatively try to compare. And if we go here, we have, say, let's refresh it. So yeah. We have many. Yeah, we have probably around a few hundred, and yeah, so that is. We don't see much. That's actually JSON of all the conditions as a club, but yeah. So we can later, maybe like in the future, we don't start from the dummy. We can start from this and work from here or apply it to other time frames and see what happens.